Hello student, today we are going to learn NCRT example problem. It is a 10th exercise problem. It's a 10th problem from 7th chapter, which is called alternate current. Okay, the problem is based on the its resonance condition. Okay, there are three frequencies given: 800 kilohertz and 1200 kilohertz. From here to here, 1200 kilohertz. Okay, it is a frequency is given. The inductance is connected in the circuit is going to be the 200 microhenry, which is given in the question. Okay, they asked if you want to adjust from here to here, what is the capacitance range you want? What is the capacitance C1? What is the capacitance C2? Okay, first I should relate with frequency, inductance and capacitance. These three I have to relate with in a single equation. See here how I am going to relate. Okay, XL is equal to XC, omega L is equal to 1 divided by omega C. So omega square is equal to 1 divided by root of LC. Omega square is equal to 1 by LC. So omega we can write 2 pi f. Okay, otherwise omega is equal to 1 divided by root of LC. We can write like this type of equation for resonance condition. Angular velocity is going to be angular displacement by time. So omega is going to be theta by t. 1 by t is going to be frequency. So theta will be 2 pi. 1 divided by t is going to be frequency. So 2 pi f is equal to 1 divided by root of LC. If you want f, frequency 1, which is given already, 1 divided by 2 pi root of LC1. If you want frequency 2, it's going to be 1 divided by 2 pi root of LC2. Okay, F1 and F2 is given. Now we have to find C1 and C2. Just squaring of this equation we can get as a C1 and C2. Okay, so F1 is equal to 1 divided by 2 pi, or it's going to be root of LC. Okay, it is C1. If you want C1, just square this. F1 square, 1 divided by 2 square will be 4 pi square LC1. Okay, if you want C1 is equal to 1 divided by 4 pi square L F1 square. Okay, if you want C2, C2 is equal to 1 divided by 4 pi square L F2 square. Okay, now I got what is C1 and what is C2. Okay, now we are going to find what is C1 value. C1 value is equal to 1 divided by 4, 3.14. Okay, it's a whole square. Then what is inductance? Inductance is given 200 microhenry. 200 into micro is 10 power minus 6. Okay, and for initially the frequency is going to be 800 kilohertz. 800 kilo is 10 power plus 3. Okay, if you are doing this full calculation, I will get capacitance of capacitor for initial state is going to be 197.7. It is into 10 power minus 12 farad, which is going to be called picofarad. So 197.7 into 10 power minus 12, that's going to be picofarad. Capacitance of capacitor at first case, it's for 800 kilohertz. This much capacitance of capacitor is required. Actually, capacitor we can call as a tuner, radio tuner. Okay, so now C2 value, I am going to calculate what is a capacitance. Second value it's required. What is the value we can increase? Okay, that's a question, actual question. Okay, C2 we are going to calculate. C2 is equal to 1 divided by 4 pi square, which is going to call 3.14, and 1200 kilohertz. 1200 kilo is 10 power plus 3. Kilo is 10 power plus 3. Okay, and it is inductance 200 micro. Okay, 10 power minus 6. If you are doing this calculation, you will get what is a C2 capacitance. C2 capacitance is going to be C2 is going to be 87.8. If you are doing this calculation, 87.8 picofarad. Okay, so one thing I learned, when the frequency F1 to F2 range, if you want to increase the frequency range, you should decrease the capacitance range. That's a thing we have to get from this calculation. Okay, when we are increasing the frequency, when the frequency range if you want to increase means you should decrease the capacitance value. Actually, the capacitance we have variable capacitance which we can alter the value. Okay, that's the thing. It is the 10th problem. It's from alternate current. Okay, thank you for watching my channel. If you like my channel, please subscribe.